Hello class, my name is Zan Ryan. I'm going to teach you about arc length. What you need to know for the test is mainly this equation. From b to a, 1 plus the derivative squared dx. All anti-direct. Alright, let's look at how that formula was made. So if you take a simple curve like y equals sine of x and graph it, you can look at the different points and try to find, the total distance between these points. Well, the distance formula can get you a little far, although it'll make it really straight like that. And for that, it's this, x of b minus x of a squared plus y of b minus y of a squared, which is also change in x squared plus change in y squared. And surprisingly, it's also d of x squared plus dy squared. Now, how this turns into our formula is that you take the d of x squared out. You move it. So it's 1 plus dy squared over dx squared. And then you take the dx squared and put it over here. And that turns into, this is really just f prime of x, but squared. And this is on the outside, which is really cool. But why is it an antiderivative? Well, that's because if you take a look at all the, let's say this one, and you divide it up into little intervals called I. Each one is I length. And the number of intervals is n. Now, you want I to keep getting smaller and smaller, and n to keep getting bigger and bigger as you take more and more intervals. So n is going to go to infinity. And you've seen this before. It's the limit as n goes to infinity. When you add up all of the intervals between b and a of that distance, this whole distance formula here, I'm not going to write it again. And then this will be the arc length L between your defined b and a of the arc length formula. See? That's the same thing as at the top here. Look at that. Alright. Let's do a practice problem. Let's do another simple curve that we like x squared plus 4. We all know what that looks like. It's just 4 units up, and then a parabola. Let's do it as x is between 1 and 4. So between here and here about. We want the length of that curve. So we'll just use our new formula that we just derived here. And we'll do it from 4 to 1 as 1 plus y prime squared dx. This is all L. So to take that, we need y prime, which is just 2x. That's beautiful. This is going to just be 4x squared plus 1 dx. And this is interesting because it's hard to actually integrate. So this will be one of the calculator arc length problems that we'll see on the exam perhaps. I already did it here. So if you do what I did, just plug it in, use math on your calculator if you want that. But you know where to find f of integral. Right? And it gives you all that. So your answer should be 15.33. Or wherever you want to round that to. Let's look at a harder problem. Let's look at a harder problem. This is something I copied from the AP test in 2011. They give you the graph of this f of x, but they don't tell you the equation. But they do give you all this info, and the domain of x from 0 to 10. And they give you the area between 0 and 5 and 5 and 10, and they give you the arc length between 0 and 5 and 5 and 10, which is cool. So they ask you this hypothetical function h, and set it equal to our f of x over here. They give you the derivative of h of x, which is nice because that's what we'll have to plug into our formula. And they set it equal to the derivative of f x over 2. And we need the arc length of y equals h of x between x equals 0 and x equals 20. Which is weird because it only goes from 0 to 10 for f of x. So we'll plug in our arc length formula for h of x. Right, we'll put its derivative here. And then we'll sub in our known b and a and the simpler formula for the derivative of h, which is this. Now we just need a u substitution for x over 2. So we'll set u to that, du equals 1/2 dx, and that'll go to, we'll put a 2 on the outside here, and the u will be like, we'll divide our interval numbers, x over 2, so 20 over 2 will be 10. And that'll fit in our domain up here, all the way there. So this is the arc length for f of u, which is the same as f of x, just with a different variable. And we can break that up into parts, which is, sorry, that's not 1/2, that's 2, times everything from 0 to 5, everything, plus 5 to 10, everything. I don't feel like writing it again, but it'll be 2 times the value they gave us for the arc length of f of x from 0 to 5, the arc length of f of x from 5 to 10, which is 11, 18. If you want to see, they gave us it right here and right here. See that? So you just have to plug that back in, which is tricky because it's like hard to bring back, I guess. 29 times 2 will be 58, and that's the right answer. So I hope this clears things up, and I wish you luck on all the practice problems. Goodbye.